Hi, my name is Richard. My call sign is WC8RK, and I'm going to show you how to build VHF antennas with PTFE or Teflon inserts holding the elements. I'm going to show you how to put a 3/16 element into a 1-inch aluminum boom with PTFE insulators. First, you have to drill 5/16 holes in the aluminum. I use a vortex point bit, which I like very well, and I lubricate it with kerosene and drill the holes using a drill press. After the holes are drilled, you have to deburr them so that the PTFE inserts can expand and have good grip. I use the external and an internal deburring tool to do that. You have to put them in a vise or clamp it down to your workbench. Then I take one insulator and put it in from the side I'm working from, the other one from the opposite side. And to hold that one in place and to keep it from overexpanding, I use a block with a countersink. Put the countersink over, put on a nice little clamp to hold it in place. And then I take a tool which is made from a 13/16 water hardening drill rod. It's about 5 inches long, tapered for half its length down to a very small point. And I judge the point by putting them through 2 insulators, and I want to see a little bit sticking out. On the back side, it's counterbored so that a element with a very, very small chamfer, and I'll show you how that works, fits in that counterbore and follows the tool through when it's being inserted. So I also use some WD-40, and yes, I know it's not a lubricant, it's a water displacing product, but I use it all over the place. And I have a handle that can work as a T or as a long thing for pushing in elements, or the blunt side, and you'll see what that does too. So I'm going to put it through. The secret is to find the one on the other side. PTFE has a good creep capability. I use the blunt side to push it flush. So the tool is now in there, and it's 15 thousandths long. I put a line on the element to let me know when to stop pushing the element through. It happens rather quickly. I skipped a part, and I should tell you, before you put the element up to the insert, you take a tool that's going to put a small chamfer, and you have to have a tiny chamfer on a 3/16 element, which I use this low-speed drill and this tool for to put that chamfer on there. Okay, that's it. I'm going to show you how to make the PTFE insert tool. Now remember, you want it to come to a point to expand these to the 13/16 that this water hardening drill rod is. And I show 2 inserts on here with a little bit of a point coming out, and that's about how I like to have them. And the 5 inches is tapered, the first half of it. And the taper, the way I judge the taper is to put a straight edge up against the taper And you can see I got a little bit of a gap at the point, but not much. That might be a better picture, okay? Then the back of the tool, to receive the element, you work it on a lathe and you spot a center drill hole, and then you take a larger diameter drill and make a recess for the element to fit into. So the way I start off is to cut that 5-inch piece, put it in my portable drill, and then go to the belt sander where I have a 1-inch belt sander where I have a aluminum zirconium belt on it.
The material for the PTFE insertion tool is made out of Watercraft water hardening drill rod, 13/64 in diameter.
So I run the drill opposite the direction of the belt, and I usually run it at an angle across the belt. And this is water hardening drill rod, so I keep a cup of water here to cool it off when I have to. So I'll give you a little bit of a taste of this. It takes a while. Tapered the insertion tool on the sanding belt is going to be quite rugged. So I put it in my drill press and I run the drill press at about 1,000 RPMs, and I use emery paper, good King's pour emery paper. I use 400, 600, and 1200 grit. I lubricate the paper with WD-40. No surprise, right? So I start by spotting the center with a center drill very lightly in the back of the drill rod. And then I change to a standard drill bit. And let the drill bit create the recess in the back of the tool for the element to sit in.